So what I have on the bench today is a BWD Select voltage regulator. This came off of my 78 Dodge D100. I had it for about 2 weeks, maybe 5 miles on the truck. I hardly drive it. And it started cutting in and out at idle and then eventually stopped charging. And then it charges for a little bit once the vehicle is restarted. I had previously warrantied this from another BWD Select regulator, which lasted for a couple months and then started overcharging the battery severely. I believe it was charging at about 18 volts. So we're going to do a bench test on this and see if we can see what the problem is. So this handy little diagram came with the Ecline replacement I got from Napa for this, which so far is working fine. We'll see how that lasts. So basically what this is going to do is ground the field winding to energize the alternator. So if you see here, one side of the field winding is hooked up to the ignition circuit and the other side goes to the F terminal on this voltage regulator, and then the I is the ignition voltage that comes into the regulator, which it senses. So if it's below, should be about 14.4 volts, somewhere around there for the charging voltage, it should ground this wire. So what we have hooked up here is we have it hooked up to a variable bench power supply, and this red and black pair here, you can see that the red is hooked up to the ignition input and the black is grounded to the case. And then we have a test light which is hooked up, it's clipped on to the ignition voltage at the power supply, and then the other side of the test light is hooked up to the field winding. So when we're below the charging voltage, this field winding should be grounded and it should light up the test light. So now we'll kick on the power supply, have it set to, it's about 12.5 volts. The voltmeter is just hooked up in parallel with the power supply. So as you can see, the test light is lit, which is good. This is a normal battery, fully charged battery, be about 12.6 volts. So this is a pretty normal battery voltage after you start the vehicle. So now I will try to get this all in shot, and I'll ramp up the voltage on the power supply. Look at the meter in the top left. 14.6, we're getting a little high. 14.8. Saw that the light kicked off at about 15.1 volts. So now it is not charging anymore because the field winding is de-energized. So now if we drop below our charging voltage, the light should kick back on. As you can see, I'm already on 13.5, 13.2. We'll go all the way down to 10 for good measure. Or 9.7 there. We'll come back up. You can see the light is not on. So at this point, it energized the alternator. If the alternator was able to supply enough current to go over the 15 point whatever volts it was, then this would have kicked off and not come back on until the battery's severely discharged. So let's see where it actually does come back on. And what we can do here is I'll bring you up to the power supply, and you'll notice when it starts energizing the field, you'll see the current from the test light. So you'll see the ammeter on the left jump up. So we'll just slowly ramp this down. See that jump up? We're at 4.9 volts just about. See the light dimly lit. And then of course it'll get brighter as we bring our ignition voltage up. And then, so we'll go all the way up till it kicks out again. Way too high, but kicks out. So let's see if we can see if we can get this thing apart, figure out what the failure is. Turn off this power supply. It is a completely potted module, so that might make it difficult. Don't know if we'll be able to do it, but let's see if we can get inside. One thing I have noticed, I'm looking through the camera here, so it's kind of hard to see. One thing I have noticed is the potting is, there it is on this corner over here, started to separate from the case. Now, I don't know if you can hear this, but you can kind of squeeze it and you can hear that like the front is separated as well. I don't know if you heard that, but it makes kind of a crunching sound there. So I'll bring you back when I have this apart. So I have it apart this far now, which was way too easy to do, which I'm guessing is going to be related to our failure. I just kind of put it in the vise, tried to bend it down a little bit, and started prying up from where it had already separated. Kind of just went around it, prying a little bit with a screwdriver. And then this whole centerpiece came out here. This is after I drilled out the rivets, of course. And then a couple of these connections broke here, but it looks like this whole section here just has the connector, and I don't know if you can see them, yeah, some little wires that went to this little circuit board that's under here. One of these broke, one of them I cut off, and you can see this potting compound is just, you hear that, it's like, it's not hard at all, it's just powder, and it smells terrible, but I'll try to get this all cleaned off and get to the circuit board. Alright, most of this potting just fell away, and then I was able to brush the rest off this board with a toothbrush. It's just this powder stuff. And if you can see, here's the board. It appears to be I don't think it's fiberglass, I think it's a ceramic substrate. I'm seeing some green, so I might be wrong. But if you can see, it looks like it has silicone conformal coating on it. And it's starting to peel up in this corner over here. And I'm kind of wondering if maybe the silicone wasn't cured when they put the potting compound and it outgassed into this and did this, or just the silicone conformal coat had some reaction with the potting compound. I don't know, but that's kind of my guess as to why there was this, thick layer of just weird powdered, uncured potting in the front of this. So I'm going to continue on and take the conformal coating off this, see if there's anything that'll obviously let the smoke out. Beyond that, probably try to write out a schematic from this, and then we'll go from there. So I don't know how well this is going to show up on camera, but we see here in front of, towards the top of your screen here, this is the tab for what I'm guessing is either probably an output FET or an output Darlington. So this is, I haven't traced it back to the connector, but I'm guessing right here this is the output for the field winding. If you see, the copper under there is corroded, and it's coming over here in between these resistors, which look like to be a voltage divider most likely, and so it's looking like that it's leaking current from the output to the input here, which could really explain our problem. So what I'm going to do is trace these connections back to the connector, make sure I have this hooked up right, and do another bench test, make sure we still have the issue, and then I'm going to just try to clean off the corrosion and see if this comes back around. Well, I have picked the conformal coat off, traced out the connections and hooked it up in the same manner as I had before in the initial bench test. And unfortunately now, as you might be able to see if I get the glare off the multimeter, it is working as intended. The charging voltage is a little high, but it does appear to be working. So up in this corner, let me turn off the power supply if I can get this to focus. So up in this corner here, you can see all this copper corrosion here. The conformal coat had separated from the board and it came off with bits of corrosion in it. And if I can get a good shot here, you can see, okay, you can see this, the solder mask is coming off here and it's eating into the copper all around here. And then this copper has corroded here and migrated over to these resistors here. So I'm thinking just the act of picking this conformal coat with all this copper in it off of here has probably fixed this. I might just brush this down and see if we can get that voltage to go down just a little bit, but this looks to be the failure here. So I went ahead and cleaned this off a little better and retested it, and unfortunately there was no change in the voltage. But let me zoom into this area here and see if you can see it was really tracking to that resistor on the top there. And as you can see, it's actually supposed to be connected to the one on the bottom, but there's kind of a lighter part there where I kind of scraped up where it was tracking in between. I don't think it was supposed to be connected there, and I really don't know how it wasn't still leaking with how much corrosion was still in between there. I'm guessing this is just copper, and it was migrating because there was some moisture on there when the vehicle was on and there was current running through there. I don't know. It doesn't look like dendritic growth from the solder. I'm not sure. I think it's just migrating. But yeah, so there it is. I wouldn't recommend buying this. Here's the markings on the back. It says made in Taiwan. It has this number here. The last one I bought, I believe, said made in China, and then when I warrantied it, I got one that was made in Taiwan. So yeah, stay away from these. I'm back on this BWD Select voltage regulator. I went ahead and traced out the schematic. I used this no-name component tester thing for the first time, which helped quite a bit, but I think for the output transistor, it was telling me that it was a PNP, and it sure seems like it's an NPN Darlington, so I don't know if anybody's used those, if they've had the same kind of issue with that. So here's the schematic, and basically what happens here is you get a voltage divider that goes into a Zener diode that's connected to the base of the transistor on the input. And did the math over here. When this gets to 13.38 volts, 39 volts, you have current that flows here through the base of this transistor, which is going to pull this to ground here, which is going to pull the base of the output transistor to ground, which is going to turn off this current path and turn off the field winding in the alternator when it gets to the desired charging voltage. Now, before it gets to that point, you have the ignition input right here, and that's going to turn this output transistor on through this 1K resistor. Now, there doesn't seem to be, other than this diode right here, which is it's a freewheel diode, so when this output shuts off and the field collapses in the field winding, you're going to have a spike here. So what this is doing is it's just shunting it back to the ignition, and the battery can filter it out. So beyond that, there sure isn't much transient suppression on this. There's no overcurrent protection for the output. The output transistor is in a D-pack, which I couldn't find the data on the transistor, so I can't say for sure, but I suspect that that's really undersized for driving a field winding in an alternator. I went ahead and measured the DC resistance on the field winding that this is driving, and it comes in at 2 ohms, which I couldn't find an exact number, but that seems to be in the ballpark from what I've seen. This output transistor is marked MORE PO284. Couldn't find any data on it. No idea what it is. If anybody's seen it, please comment. So where we saw the corrosion was over in this area right here, between this resistor and this pad here, which is the output for the field winding. If you look at where that is, that's between this and that's this side of the resistor. So it's basically corroded between the output and the base of the input transistor, which could certainly could throw off our threshold. I would have really liked to see the failure on the original that I warrantied in here, where it was overcharging. I would venture to guess that this transistor just failed short, just due to how much current's going through it and the size of the package and being able to dissipate that much heat through that package. These RC circuits here, I'm guessing that's just so it doesn't oscillate at a high frequency when it's right close to the set point. Yeah, so that's it.